Morning. Good morning.
Morning. Why don't you all practice on number 1 we didn't do. Go ahead and do number 1 and number 5. 1 and 5. We're warming up with this one. Good morning, everybody. It's 8:30. You're working on this first problem here. You're going to write a quadratic function whose graph has these characteristics. The vertex is located here. And it passes through this point. Since we're going to be writing this, they give us the vertex, we're going to write it in vertex form. By now, you should be very familiar with the 3 forms. If you're not, then you're not coming through this journey with us, really. You're on the fringes, you're on the outskirts. You need to get in here. Get with the program. All right, so you have 5 variables. 4 of them are given to you. Find the last one, which is going to be A. Then you're going to rewrite. What's constant in a parabola in vertex form is A, never changes, and the vertex doesn't change. X's and Y's change along the parabola. There are different X's and Y's, but there are not different vertices, right? And it doesn't have a different A along the parabola. A is something that's true of the entire thing. The vertex is the vertex for the parabola. So those have to be represented by constants. So this needs a number. This is going to need a number. This is going to need a number. When you finally write it, X and Y will stay X and Y. But for now, we can choose a point, and it must satisfy the equation. That's what this being on the parabola means, that this is a solution of the parabola. So then we can use this Y with the unknown A, with that X, minus the H that's part of the vertex, 4, squared, plus the K, which is -5 at the vertex. Okay? And then we simplify. -2 squared is 4. Add 5 to get +4. A is 1. You now have all 5 variables. Remember, you only want to fill in those. We already had H and K here. Okay, now you have A as 1. So you rewrite Y is equal to, you don't need to write the 1, X minus the H. If the H is negative, make sure it's minus negative. That should be positive. Take notes of these things. Don't just watch me. You know, if you know that you struggle with these details on tests, you miss details on tests. Then when I say something that's about a detail like that, that students miss, minus the negative becomes plus. That's a detail that gets missed. Make a note of that and start making your cheat sheet now of what you want next to you while you're taking the test. Okay, and then plus K is -5 here. Questions? I think that's one of the easier cases of this type of problem. Now, of course, I can give this to you graphically. I don't have to give you this in pink, right? I can just show you the graph and you can see with your own eyes where the vertex is. And they might show you another point on it, right? So they don't have to show it to you this way. They can show it to you with a graph, or they can show it to you this way. All right. I think I'm going to move on. I think I want to start the review soon. So, because we'll cover this in the review. I don't want to double cover now. I think we got it. And I think we're warmed up. Okay, the next problem is not really anything we can do. You kind of just have to sit back and watch. So if you look here, it says quadratic regression. So I don't know if you guys in algebra did linear regression models. Did you guys do that?
Don't think so.
No.
That's where you're
Heard
taking.
of them, but we didn't do them.
So what's happening is you're taking data, right? And in a linear situation, we can graph the data. Okay, so let's say that we have some data. For every X, there's a Y, it's a relation. And you get what's called a scatter plot of data. And you notice there's a positive correlation. As X is increasing, Y is increasing. Or it could be the other way. But you notice that it's not randomly scattered. And hopefully you can see, you can see my points, okay. So what you do is you try to come up with a model, a line, what they call a line of best fit, that goes through what seems to be the average of the data, all right? And what you can do is you can follow that back and come up with a point there, and you can come up with some other point there. And if you're given 2 points, right, x1 and y1, and another x2, y2, then you can write the equation of a line. Then what you can do is you can use your line to make predictions about data, about things that happen later on. If x continues, what is y likely to be, right? Then you can measure what we do in statistics. On average, how far away is data from your line, right? You're trying to create that a line of best fit is going to minimize the distance data tends to be away from your line. Well, it's no different with a quadratic model. If you see that data is given and the data is scattered in such a way like this, then it's possible that your data is following a quadratic pathway. And what you would do, same thing, you would try to find that quadratic that best fits the data. And then you can answer questions about points of interest, right? Points of interest, where they're likely to be. So this is a model, it's not an exact, it's what you use to predict things, okay? So that being said, now you know what this is. We're not gonna be doing this. This is graphing calculator stuff. Okay, but let's just look at the example so you get an idea of what they're using it for. Okay, quadratic regression, best fitting quadratic model. Okay, a pumpkin tossing contest is held each year in Morton, I thought it said moron, Morton, Illinois, where people compete to see whose catapult will send pumpkins the farthest. Should it be furthest or farthest, Søren?
Well, what was the original sentence? Here we
Farthest.
go. Where people compete to see whose catapult will send pumpkins the farthest.
Farthest.
Farthest, I said.
What did I say? I think
Yeah.
farther,
Well, actually, in
farther is for distance or further is for distance. I don't know.
No, further is.
I'd suggest either, but there is some sort of precedent that you use one for metaphorical distance and one for physical distance.
Yeah, I believe so. Okay, here we go. One catapult launches pumpkins from 25 feet above the ground, right? So that's your y-intercept, starting at 25 feet above the ground at a speed of 125 feet per second. The table shows the horizontal distances in feet the pumpkins travel when launched at different angles. Okay, so look at that chart. Look at what the x's are. That's changing the angle. Steeper angles, right? Now, as you steepen the angle, you might start it, you know, when you're starting flat at 0, you're launching it straight ahead, right? So if you launch it straight ahead, you're going to get one result. Now, as you lift up the catapult angle, you'll notice your pumpkin starts going farther. But what happens if you launch it straight up? It's not going to go anywhere. It's going to go 0 feet, right?
Yeah.
It'll just come right back down. So what happens is, in the beginning, as you increase the angle that you launch it, it's going to go farther, but to a maximum. Once you reach some maximum angle that will get you the maximum distance, it looks like it's about 40 there, right? But you're not sure if it's 40. What if it's 41? When did it start to go back down again? When did it max out? So what they're saying is, this would be a case where you can use a model, a quadratic model. So just take a look at what they're doing. Now that we have Desmos, I don't know if you could probably do this in Desmos, but in a graphing calculator, take a look at step 1. What they're doing is they're telling you to make a table. So you can go to a table in your graphing calculator, and you're welcome to do this if you want, but they're putting in the values that are in this table. All right, L1 is going to be the angles, L2 is going to be the range values, right? The y values, the distance in feet. Okay, so then what happens is you can tell your calculator to make a scatter plot of the data. And then you see that it has a parabolic trend, a quadratic trend. Once you see that, you go to step 3. Use the quadratic regression feature to find the best fitting quadratic model. So your calculator will just do the quadratic regression. It will suggest what A, B, and C are. Okay, so look at what it says. It suggests that A is negative 0.2614. See, your calculator is going to get a good accuracy there. It suggests that B is that. It suggests that C is that. Okay? All right, and then it says check how well the model fits the data by graphing the model and the data that you had in the beginning in the same viewing window. And then look, that model fits those points. All right? Now look at the follow-up question is where it gets useful. Look at this follow-up question. At what angle does the pumpkin travel the farthest? Well, where would that be on the graph?
Geometry.
It would be at the maximum.
Yeah, at the maximum at the.
Right? So you could solve for the maximum point, right? And then that would be your prediction of what angle to fire off your catapult. And there it.
Well, another interesting thing you could gain from this. Sorry to interrupt. Another interesting thing you could gain from this is how it's the process. How exactly do computers compute a formula that exactly matches a quadratic pattern or a quadratic scatter plot? And just a cursory search will inform you that that there's a specific system of linear equations that they solve in order to produce the values.
Okay, fair enough.
I'm pretty sure there are algorithms in several programming languages for this.
I'm sure there are. Okay, let's see.
Yeah, with most C-based languages, it's pretty easy to create a data. You can create a data set with this and then just plug it into a data set and it'll give you all the answers.
Nice. Okay, look.
A few years back, I coded something similar to this. Now, I don't quite remember how to do it, but it's very possible.
Well, as long as if you're enjoying it, that's all that matters, right?
Is it possible in Python?
I'm not sure. I'm not the hugest fan of Python, so I haven't really
I'm sure it is possible in Python, sir, and there's probably already a function that does it.
Yeah, sir, and I mean, most coding languages in the end have the same abilities. They're just versatile and better for certain things. Like a lot of C-based programs are used for application in engineering versus Python, which is more used for like LEDs or running programs inside the code.
Scientific programming, actually, that's another thing. A lot of people use Python for scientific programming and data manipulation.
Okay, guys, it only went up to 45, so you're going to do evens, not every fourth. That's due next Friday. It's due.
Oh, 410? Yeah, I already did that. Okay.
I worry about making it due next Friday, actually. So you know what? I'm going to have to change that. So I have to change that. You know why? You kind of get why I have to change that, right? I have to change that because.
Oh, grades.
No, not because of grades, although that's another thing to consider. I have to change that because I need you to do this before you take the test. I don't want people doing it after they take the test.
That too.
Oh, you know what? Let's just make it Monday.
What?
22
project
problems
due this Saturday.
What?
We have like a whole project due tomorrow.
Do it Sunday.
And another thing due we have another thing due Sunday or Monday.
Listen.
If things due Sunday, you could do it Sunday. Or you can do it today.
I don't know if you've noticed. I have not been dinging anybody for late stuff. Did you notice that? I have not been dinging anybody for late stuff. Did you notice? You didn't notice, did you?
Yes, we have.
Okay.
We noticed.
Okay, so some of you noticed. So don't stress out about it. If you can fit it in. What you're doing if you don't, I'm just warning you, is you're not practicing for the test if you don't do this. If you save it for after the test, it really becomes purposeless, which is why we really shouldn't be accepting late homework. I don't want to penalize you for not accepting late homework because you already penalized yourself on the test, right? And then if you didn't, and if you knew it anyway, then you didn't really need to do it, did you? So that you guys waste a lot of, you spend a lot of energy on things that are not actually important. I guess I do too. I am guilty of that myself. Okay, so take a brain break. We're going to start our review as soon as I can pop that up. When we finish our review, that's when we take the test. So if somebody's starting to formulate that question in their mind, when's the test? You know when the test is, when we finish the review. If we don't finish the review, we're not taking the test, but it's not going to be any later than Tuesday. So let's say we don't finish the review today, then we'll finish it Monday and take the test Tuesday. If we finish the review right now, because it's mostly skills-based, well, then we can take the test on Monday. All right, here we go. All right, here are the big ideas from the chapter. It's been a long chapter. It's been a long chapter because we've drawn the chapter out on purpose. We wanted you to master this so that when you go into advanced math next year, it's an entire chapter that you don't have to worry about. Not only that, understanding one chapter in great depth is you're going to see all these connections when you do conic sections, ellipses, hyperbolas, translating them. This is going to give you that foundation so that becomes an easy process for you. All right? So my goal is that you get to zoom through Algebra 2 and get to that pre-calc that you're going to need, limits. And then the bigger goal is so that you have time to thoroughly get through Calculus AB and be able to take that AP exam. I strongly suggest over the summer that you guys all start brushing up on your Algebra 2. Look ahead. Go way ahead so that your teacher can move more quickly through it. When your teacher can move more quickly through it, they can get you to that Calc AB and finish it so you can actually take the AP exam on that. It is a tight fit. Some of you will not be ready to take the AP exam if you don't take it seriously now. It's going to be too difficult to catch up. Okay, here we go. I'm pulling up the review on my other device.
AP exam for which?
For Calc AB, not this next coming year, but the year after. We're finding.
Oh, I see.
We are finding right now that it is difficult to get all the students everything they need in advanced math, Algebra 2 and pre-calc all in 1 year. What we're finding is that in the following year, in the Calc AB year, that the students need so much brushing up on the pre-calc, they're not ready to handle the calculus. And so we're spending so much time on pre-calc brush up that they're not finishing the B section. So we need to get you so you guys are ready to go for the Calc A section right off the bat so you can get the full Calc AB course. It's crucial right now that you don't lay off the gas. Finish this school year super strong. You always run as fast as you can through the finish line. Then you get your summer break, and it'll be well deserved. Don't go on break early, okay? Push yourself. Don't hurt yourselves, but push yourselves, okay? It's gonna make you stronger. All right.
Just got 10 more days.
Yeah, exactly. And those 10 days, you should be working harder than you ever have this semester. These should be the hardest worked.
I'd say, are you sure, Mr. Osdo? I'd say it should follow more of it's like a
quadratic pathway where you're laying off.
The hardest you work the hardest. Well, maybe not with the slope of line. Yes, you work the hardest in the middle of the school year when there's most work being assigned and when it's the most crucial because exams are coming or exams have already come, and because of winter break, that's
or
the
should it be a flat line where you work, or should you be working the same at a steady pace, a flat line of work?
Well, that's idealistic because at some point students are going to start tiring out, and better to have them work the hardest in the middle of the year and then slowly reduce the pace of the work until at the end of the year a very small quantity of work is being assigned and classes are going at a much slower pace.
Well, in a
That doesn't
story,
happen, though. It just speeds up.
When you guys are learning your English,
That doesn't follow Lao Chu's.
the climax of a story, does it happen in the middle of the story or at the end? And if
middle,
the climax,
end is the
Middle English.
if the climax happens
The middle
too
of the
soon,
end.
they say that it's anticlimactic and people don't enjoy the whole thing as a whole. You
Wait,
lose value.
when it occurs in the middle, you're saying, Mr. Osborne?
If it occurs too soon. Whenever
This
might be.
isn't occurring too soon. I mean, if you just analyze the amount of work every student does in general throughout the year, you'd notice that on average, doesn't it tend to peak around December to January? December, January to February. It should, I believe, it should tend to peak at that point.
Not me.
No, because we're fresh off of
Winter
winter break, so we're lazy.
That we have to do.
Not me.
When you're fresh off of winter break, you're assigned more work in order to get back to the pace you're at which you were going before winter break, and so probably at the largest amount of work might be actually maybe March as well. But what I'm saying is after winter break.
Okay, enough.
Break is when.
Enough. This is my suggestion. I don't suggest working like this is how hard you work, right? So this is how I don't want to write that all there, but you can see this is how hard you work. I suggest instead of this, I suggest this. Now, notice that this one, you're working harder at your maximum than you ever worked on this. This is called pacing yourself.
But Mr. Osdo, isn't that
Wait. You suggested that you would burn out. Well, then that means that you need to lower this until you reach an optimal that you can work at a steady pace the whole time. This will bring you, I predict, will bring you this, balance. This is unbalanced. This drives you nuts. This makes you crazy. Up and down, up and down. You need to find a steady pace throughout your life where you can work like this. Then you're in balance. And you'll never be like that. It's going to be like this. This is just a line of best fit. You're going to be working too hard at sometimes. Sometimes you won't be working enough and you'll feel bored, right? You're always trying to get to there, I think. I don't think this is good for you. I don't think this in your life is good for you. It's unbalanced. Anyway, let's move on. Yeah.
Can we,
what?
Also, I sent a question in the chat.
Using math to suggest life strategies.
I sent a question in the chat.
Hold on one second. Thanks, Jack. Oh, you sent a question? Okay. Oh, you brought my attention to the chat room. Host only. Sorry.
Yeah,
We were
he
passing
did.
a motion to impeach homework.
How dare you?
Lightning Secretary of
They
State.
were trying to get rid of all. They were trying to stop doing all homework.
All right, guys.
David, did you do that on purpose, or
Yes.
was that your sting operation?
Yes,
Why?
Hey, I'm the
Guys.
Secretary of State at least.
because they were being mean to me and kicking me off the Discord server. So
Oh,
We're
okay.
not
Well,
them.
that's
That's
understandable.
dumb because we wanted him
Okay,
to be
if
the judge instead of you, but you know.
Because we need an impartial judge.
but you kicked me off the Discord server.
Which makes you not impartial.
All right, guys. You guys.
Dr. Jersey.
Hey, you guys are hijacking the lesson, by the way. I'm allowing you to talk a little bit because I really do want you to get some social time. But it's kind of negative what you're talking about. So, all right. So here we go. Big ideas that you need to take with you. Again, you can print this out and have this next to you. This kind of is a cheat sheet, isn't it? Right? This right here is a cheat sheet in a way.
Yes.
Standard form. It tells you guys can see my mouse, right?
Yeah.
Okay, it tells you what it's for. Graphing and writing quadratic functions in several forms. Okay, you have standard form, tells you information about it. The x-coordinate of the vertex is at negative b over 2a. So is the axis of symmetry. There's the equation for it. It's a vertical line that goes through that x-coordinate. Here it shows you vertex form. We've worked extensively with all these, so this should be enough to spark that. If not, you need to be in office hours. You need to do something, talk to your peers. If this looks totally foreign to you and you have no idea how to work with this, you have not been engaged enough. You need to engage now. You are almost out of time, okay? Your axis of symmetry is x equals h because h is the x coordinate of the vertex. Okay, here's our intercept form. It tells you the axis of symmetry is the average between the roots because we know the axis of symmetry is right between the roots. Okay, moving on to the second big idea. I like how this book is. You know, this book is very organized in, you know, wrapping it all up in a different way. See, different textbooks have different ways of providing you material. This is what I'm used to. You know, I'm used to it being so organized and laid out, and so you can collect your ideas in an organized fashion. Okay, there are several different methods you can use to solve a quadratic equation. Okay, so without an x term means there's no b. B is 0, right? So it says isolate the x squared term, then take the square roots of each side is what they recommend. You don't have to. But I think that that's simplest when you don't have a bx in there. Okay, if it's factorable, we always try to factor it. If it's not factorable, I don't suggest completing the square. I suggest using the quadratic formula. However, it might be the case on the test that you need to complete the square. It might tell you you must solve it by completing the square. And then when I grade it, I'm not just checking your answer, I'm checking to see if you actually did it by completing the square. Now, you could always check your answer using the quadratic formula to see if you did it correctly.
And in some cases, you might want to use completing the square instead of the quadratic formula.
If you are trying to get something into vertex form, yes.
Well, yeah. So, although it does really, to me, it does really seem preferable.
For solving, I think that using the quadratic formula is the end result of completing the square. Why not go to the end if you know how it's going to end already? Unless you're just enjoying the story of it. You like to watch it develop. If you enjoy the development of it and you are not in a rush to solve the problem, by all means, enjoy. I love enjoyment. Okay, big idea 3. Stop me if you have any questions. Performing operations with square roots and complex numbers. Okay, yes, I forgot. We have some complex numbers involved here. Okay, properties. Square roots. If a is greater than 0 and b is greater than 0, then the square root of ab is equal to, when you, look here where my mouse is, when you separate them. This is not true with negative numbers. It doesn't work, okay? Because then negative square root of -1 times the square root of -1 is the square root of +1. But we don't want it to be that. We want it to be -1. Okay? So when A and B are above 0, then you can do this. And the quotient also, you can split the quotient. See where my mouse is? You can split that quotient up. Okay? Now, this is the case where you have only real solutions. When you have complex solutions, it's because you had a negative inside. What about when it's 0? When it's 0, then it doesn't matter. The whole thing becomes 0. So we're really only talking about when A and B are greater than 0, and when one or the other or both are less than 0. Okay, so you get negative numbers in here. So we define I as the square root of -1. They're saying that it doesn't. This property doesn't work when you multiply -1 times -1 inside and separate them. It doesn't work. So then we have to say that I squared has to be -1 because that property doesn't hold otherwise. If R is a positive real number, then what you can do is you can factor out a -1 so that that's positive R times -1. And then what you can do is you can say -1 is defined as I, and then you just have the square root of R. When you square that, the square here gets rid of the root R, makes it R. But squaring the I makes it negative. Okay? So you're just going to get -R. Make sure you see that. I would print this page out. Instead of making a cheat sheet, I would have this sheet right out while you're taking the test so you can look at it.
Mr. Rosenthal, does it go like outside the radical, or can it also go inside the radical?
It cannot go inside the radical unless you're taking the square root of it. It does not. We don't usually put I inside of a square root. It goes outside. It's not the square root of I. I is the square root of -1. Try to follow what they did here. They pulled out a -1. Square root of -1 is I. And then you also have the square root of R. Okay, so that's done. Then the second case is when they square that, the I gets squared, which makes negative here. And then the root R gets squared, which just makes R. Okay, all right, looking here, what you do when you add two complex numbers is you add the real parts separately, and you add the coefficients of the imaginary parts separately. Okay, same with subtraction. And then here's what a lot of students might forget is the absolute value of a complex number. They'll probably ask you one of those on the test. It's just the Pythagorean theorem with the A and the B. Okay, the square root of A squared plus B squared. Okay, and you have that formula there for you. I would make sure you have that readily available when you take your test. Okay? There won't be any vocab, so we'll skip through that.
Yay, no vocab.
All right. Like I said, the test is mostly skills-based. All right? So let's look at 4.1. They're saying to graph that quadratic. All right? So the way that I would graph it is I would find points of interest. Okay? First, I would like to find the vertex.
Oh, this is the type of book you're using.
Wait, did you?
Is this the actual Algebra 2 book that the school uses?
No.
Yeah, that's what I thought.
No,
this
it's
is
not.
This is the math book that I use.
Was anybody even able to find the book that I'm using?
I think it's a Larson.
It's a Larson
Algebra 2.
algebra book.
It's a what?
Larson Algebra 2.
Larson algebra 2.
You think I'm using
Wait, is it California
Larson and Boswell?
McDougall Little?
Littell?
Larson and Boswell, is that
Version
the
I'm
one you mean? Because it's not Larson and Boswell. That's definitely not it.
Do you know what copyright I'm using?
Is this California McDougall Little math?
Littell.
Yeah, that's what I thought.
Yeah. Do you know what year I'm using?
Larson, Boswell, Cardinal, Stipp.
You guys know what year I'm using?
I don't think we have got a clue.
2008?
Okay, good. All right, so here we go. You're going to have to graph this.
Wait, Mr. Rosenthal, is the test from the book or did you make it?
You're just gonna have to find out. Okay. All right. So let me pull up the chat so I can see what's going on.
Really quickly, are you gonna put pictures of graphs on the test, or are we gonna have to draw our own?
Graphing is like too tedious though.
It takes like 15 minutes for one graph.
Yeah, it takes forever.
You're doing something wrong. You really need to practice then over the weekend your graphing.
That was an exaggeration, but
it just takes a long time to draw them out. It's kind of annoying.
Yeah, like if we have a bunch of them, then it gets really tedious too.
It looks like you're going to be graphing. You're going to be graphing quadratics. You'll have to label the vertex and the axis of symmetry, and then later on you're going to have to graph an inequality.
how many graphing problems are there?
I haven't determined that yet. I have a test.
Graphs are not that hard if you're making-
I have a test bank, but I don't have a test yet. I have questions I can pull from the test. Okay.
Mr. Rose, though, what if you don't like graph paper?
If you don't have graph paper, go to the store this weekend and get some.
Oh, wow.
Or you don't have to have graph paper. Look at all the graphs I've been doing. I've been doing it on this board. The board
Yeah,
is
but it's like not accurate.
mine.
I mean, no, I mean like the idea of like estimating like these
Well, I mean that I can't help you with that. You should be able to graph without graph paper.
As long as you can clearly see where the points are, it's okay, right?
Let's just say it's a luxury.
It's fine, but if you're running low on stocks of graph paper, I believe that Rite Aid and Staples have some. Actually, Rite Aid and Staples do have some. There should be more other office supply stores like Office Depot. You could try there.
Yeah, but the majority of them are closed.
Well, actually, Staples is open as long as you maintain social distancing. Yeah.
You guys, what I'm thinking about doing for the test is the test that I'm looking at here has 32 questions on it, which is too much. And there are only 2 of them are application problems. So 30 of them are skills. 6 of them are graphing problems. So I'm not going to have you do all those. But what I probably will do on this test, and I'm doing this with my 6th graders, is I'm going to give you the whole thing. And I'm going to say, pick 1 from this section, pick 2 from this section, pick any 2.
Ooh, that's nice.
And I'll probably put next to the question how many points it's worth. So it might be like a menu. You can pick different problems. Okay?
Wait, Mr. Rosenthal?
So you might be picking different problems than somebody else. And that will give me another layer of security also. I'll know if there's it's an extra clue that you did the same thing that somebody else did. You know, that you picked exactly the same problems they picked.
And also it would be a little bit easier for us to take it, because if we have to do every one of the problems that you chose, they're probably going to be the harder problems that you chose because you chose them because they're harder.
They look about the same to me though.
Okay.
Yeah, and you know what? If I think that they're harder, I might put more points next to it, so that if you choose that one, you can get more points for it.
Wait, Mr. Rosenthal, what is considered skills problems?
Skills problems are like 5, 6, and 7.
Oh, okay.
Okay. See it?
Where?
On the page you're looking at right now?
Here?
Or the
those types of problems.
It's not a word problem, Thomas. It's not like the popcorn problem. It's not like...
I like those.
It's all this type of stuff. Can you do this? Do you have the skills to just graph it? Okay, let's get into it then. How do we graph? Okay, so I say start with the vertex. The vertex is at -b/2a. All right, now let me see. How are they doing it? They want you to get an idea. They say because a here is negative, we know that it opens down. Find and plot the vertex. Okay, but they're not showing you how to get the vertex. Okay.
Wow.
So the vertex is at -b/2a. Does anybody need to see how to get that? By now, everybody should easily be able to find the vertex. Okay, if not, you really need to stay on at office hours and go over that. At the very basic, you're in trouble if you cannot find the vertex. But anyway, we can do that. Okay. X is equal to negative b over 2a at the vertex. It's in the big ideas little notes section. If you don't know where a and b and c are, that's a major problem. Okay, so b is negative 4, a is negative 1, and you get positive 4 over negative 2, which is negative 2. That's the x coordinate. It's also the axis of symmetry. Okay, so at your vertex, I usually like to put a v. It's negative 2 something. How do you find what the something is? Plug it in. Negative 2 squared is 4. That is negative. And I usually put it above or below. Minus 4 times negative 2. Minus 5. So that's 8. Minus this 4 is 4. 4 minus 5, negative 1. There's my vertex. So you definitely want to have your vertex. You also probably want to have your roots. Okay, so that's when y is equal to 0. When y is equal to 0, you then solve it. They said if it has no b term, just get the x squared on one side and the constant on the other and take the square root. If it does have a b term, try to factor it first. If not, then use the quadratic. So it looks like I can factor this. Oh, there's a negative there. Okay, what I can do is I can get rid of the negative by either dividing everything by a negative or moving everything. So I'm going to just multiply by negative 1, and I'll get this.
I'd multiply.
Wait.
And now I don't know if it is factorable. It's not factorable anymore. It wasn't going to be because that was negative.
You could use completing the square.
Okay, I'm going to use the quadratic formula. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2. And this is going to be 16. It's a 5. 16 minus 20 is negative 4. Okay. Now we're going to do, Daniel, watch what we did above. You're going to pull out, this is going to be like that.
Okay.
Okay. And so this is going to be 2, and this is just I. Okay, so you get negative 4 plus or minus 2i over 2. And then, so I don't go off the board, I'm going to come this way. X is equal to, divide by 2, negative 2 plus or minus I.
I think completing the square would have been faster in this case.
Yeah, actually, can you show completing the square?
Hold on one second. This, oh yeah, this doesn't have any roots. So when you're looking at this saying, well, how do I graph that? Because it said to graph. What you now know is that it doesn't have roots.
Well,
all right, so if it doesn't have roots, then what?
And it has to curve before it hits the x-axis.
So because this doesn't have roots, we don't need any of this. All right, if you wanted to,
we know the vertex. So
yeah.
So it has to curve down.
Okay.
It has to open down.
But why would I try to get the roots is because when it crosses the x-axis, those are points of interest that I don't want to get wrong. Okay. All right. Another point of interest could be the y-intercept. The y-intercept is negative 5.
Yeah. Oh, they'd like to see completing the square.
Yeah, but not right now. You're not. Okay. So now I have this. I can graph my vertex.
I am glad that I've started a new affinity for completing the square.
Did you?
I mean,
really?
I'd rather complete.
That's anecdotal. You can't. I don't know if you started that. Oh, I guess you did in the individual, in one individual for sure. Not for sure, not even. Just because they wanted to see it doesn't mean that.
Well, he just admitted.
Back there. Sorry. Okay. So here's your. I get this y-intercept is negative 5 because that's the c. So I can do that, and my axis of symmetry goes through the vertex vertically like that. And because this is 2 that way, then I can come 2 this way. Okay? Now, what about 1 away to the right? If it's 1 away to the right, then where is that? That's at x is negative 1 and at x is negative 3. How do I know where the point is at x is negative 1? Plug it in.
Negative 2.
X is negative 1. Negative 1 squared is 1. So then negative 1. minus 4 times negative 1 is plus 4 minus 5. Okay, so that's 3 minus 5 is negative 2. Okay, so negative 1, negative 2. Okay, then that means the mirror is over here. And there, you've graphed it. And I'll probably say just pick
How
one.
did you find that point in negative 1, 1? You just plugged in 1 or something?
I plugged in negative 1 for x here and got negative 2, which is what y is equal to.
Okay, yeah.
And x is negative 1. Then I reflected it across the axis of symmetry. So I found these 3 points and then reflected these 2.
Okay, thanks.
And I'll probably tell you to pick one of the 3 choices that you have to graph. You get probably a menu. I say the word probably because I'm going to look at it more carefully, and I could see that maybe there's another problem there where I want you to graph a certain one. So I want to give myself room to change my mind. Okay, but it probably will be a menu. Okay. Anybody need work with finding the vertex so that you can graph it, finding roots if there are any, or finding other points by plugging in different x values surrounding the vertex? I'm not going to try x is 5. I'm going to try x values that are 1 or 2 away from the vertex x. Those are the ones that I try. If you're not sure why I tried x is negative 1, it's because it's very close to the vertex. The points otherwise are going to get away from you. They're going to go far up or down from where you were. So to keep them close, you start with x's that are close to the vertex. So rule number 1 is what you want to write down is first step should be finding the vertex. Okay.
So we need at least 5 points.
Yes, 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 yes. Okay. Moving on to example 2. We're running way low on time. We're going to move on. Okay. 4.2. Graphing when it's in this form. What form is that?
Intercept form.
That's intercept form. So what you're going to do, I think I can do this just with the picture that's shown here. Look at what they've graphed. The roots based on this are 4 and negative 2. See, it's what makes this 0 is 4. What makes this one 0 is x being negative 2. Notice where the points are. Where's the vertex? It's the average of 4 and negative 2. So look at here, 4.
Then plug it in.
Look here, 4 and negative 2 divided by 2 is 1. So I know the x coordinate of my vertex is at 1. Then you can plug that in and you get, see they plug it in here, and you get negative 9.
You always get the opposites and then they multiply.
Mm-hmm. So in this form, they suggest it is acceptable to just graph 3 points.
Yay.
Any questions about 4.2?
Wait, so how do you find a vertex in this case?
It's the average of P and Q. So first, find P and Q. What are P and Q here?
It's negative. Wait,
nope.
No. 4 and 2.
No, 4 and
negative 2.
There you go. So there you look here where my mouse is. Those are your P, the P and the Q are there. You average them to get your X. Why? Because look at this red line. It's halfway between, isn't it?
Mind your P's and Q's.
That's right. This is the average between them in a straight line. It's the midpoint, if you want to take it back to geometry. You are finding the midpoint of this segment. Okay? All right. So now that
PQ plus negative P squared plus negative Q squared plus PQ over 4 equals the y value of the vertex.
Yeah, but if you want that, that's fine. You can write that down as your note. See what David, if you have that formula, what David has, you can write that in your little note section if you're taking notes right now. The best way to take notes is to have this in front of you and to write down any little tips in these areas, in these blank areas that you think will help you, in addition to what they already have here. But you should have this review sitting next to you while you take the test. this review, and it shows you how to do the problem. Right now, you're asking questions because if you read this and didn't understand what you were reading, then you asked a question. The answer to that question should be in little notes, right, in these spaces, so that when those questions come up, if they come up again, maybe they don't even come up again. If they were to come up during the test, you've already answered them for yourself.
Did we already take our geometry?
Thinking ahead is you know, taking preventative action or being proactive solves most problems. Okay.
Did we already take the geometry final?
No. Who said? I didn't say that there was going to be one.
Yay.
Oh, Mr.
No, I want to do one.
No.
Why was this chapter so all over the place? There was like complex numbers and graphing parabolas, and
they're all connected. That's why they're all connected to each other.
Complex numbers are fun.
Complex numbers are connected to quadratics because when you solve a quadratic and it has no roots, it has imaginary roots, and they want you to understand what that means instead of just passing over that.
David, exactly why do you want a final?
Because I want to do areas of regular polygons. That was fun.
You're not gonna get one.
Okay, let's move on, please. We are short
And you
on
want
time.
to hold that over everyone else just because of your desire to calculate
Okay, guys,
the area
excuse
of
me.
regular polygons?
Excuse me. Okay,
Why would I be holding-
now we're moving from graphing. We're moving to
factoring.
Solving. Okay,
Hey,
graphing.
finally, nothing
Now
to
we're
talk.
moving to solving. This is no
Graphing.
different than what you did in algebra. Okay, if you can solve by factoring, great. I don't think I need to review this too much. You would factor it, and then you're looking where my mouse is. X would be equal to what makes this group 0, X would be 16. And to make this group 0, X would be -3. So if you look here, your solutions are 16 or -3. And you need to put both. Any questions about solving by factoring? Okay.
Mr. Ostal, just to think, for number 15, would you just factor out an x, right?
Yeah, factor out an x, you'd get x times the quantity x plus 5. So
Yeah, so either x is 0 or x is -5.
Correct. And you guys can do these problems at home to practice. And you can even, if you're seeing one now that you don't know how, stay for office hours and ask me to do it.
Wait, can you do number 15 though?
Yeah. You're going to factor out an x. What would you get? Thomas, what would you get if you factor out an x?
Wait, I don't know what you mean.
You said number 15, factor out an x is what I'm telling you to do.
So divide by x?
Factor out an x. So the word factoring means to you're using the distributive property in reverse. What is in common? X. X times what gives you what's above?
Times x plus 5.
That's called factoring. When you go from this stage to that stage, that's called factoring.
Now divide by x.
When you hear me say factor out an x, I'm telling you to find what's in common, which is the x, and factor it out means by multiplication or by division. Okay? If that's equal to 0, then here, if x was 0, then this would be 0 times 5. It would be 0. So x could be 0. If x was -5, this would be -5 times 0, which would be 0. So there's two ways to make it 0.
But then you could divide by x on both sides, and then there would only be one way to make it 0. -5.
Isn't that an interesting concept?
Wait, can you explain how you got -5 again?
Oh.
How do you make this equation true? There's two ways to make it true. If x is 0, will this be 0? This would be 0 plus 5. What's 0 plus 5?
5.
And what's 5 times this 0 right here?
0.
0, so that would be true. If x was -5, then -5 plus 5 is 0. 0 times -5 is 0.
Okay, but divide both sides by x plus 5, and then you get x equals 0, and then divide by both sides by x, and then you get 1 equals 0.
But you can't divide by 0.
I said divide both sides by x.
I know that, but if x could be 0, then you can't divide by x unless you've now made the 0 solution extraneous.
Well, we already divided by x, and now we know that x plus 5 has to equal to 0.
Once I do
so
that,
x it has to be -5, which means
hold on. If I do that, x cannot be equal to 0.
well, once we divide by x, it can't be equal to 0. Now we
Right,
put
right,
that in
but
parentheses and
you
divide
see
both
why,
sides by
but-
x plus 5, and then we get 1 equals 0.
But x could be 0.
But now it can't.
You can't do that. 0 would make it true, and then you're saying, well, if I divide both sides by 0, then I make it so that it can't be 0. It can be 0.
But divide both sides by x, and if it's 0, then we get x plus 5 equals infinity.
Why don't you graph this? What does it look like? So vertex is at -b over 2a. -5 over 2. So -2.5. If I plug -2.5 in, I get 6.25. And then this becomes what? 2.5 times 5 is what? 10, 12.5, so -12.5.
Yes.
Okay, so then I get, what do I get when I do that? I get -6.25. Okay, so my vertex is there. We're running out of time here. Here, and 1, 2, 3. Here's -2.5, 6.25. Okay, the roots are at 0 and -5. This parabola looks like this. Okay, you're saying x cannot be 0, but it can be.
So you just erase the parabola just jumps over the point 0.
Here's what you're suggesting. No, you're suggesting there's an open hole there.
Yeah.
But there's not. Because you're taking something and saying, well, let me divide it by, if I have x is equal to 5, what you're saying is do that.
Yes.
Okay. What if it's true that a value is 0, can you do that?
No.
No.
Unfortunately, 0 divided by 0 does not equal 1. It equals infinity. So
You can't do stuff like that.
why not?
David, if your logic was true, after you got you get I think 5 plus x equals 0,
0.
and then you could divide by 5 plus x, and you would eliminate the other root.
Yes, 1 equals
So
0.
That would not make sense at all.
It doesn't make sense because you're dividing by 0, and that gets you around. That's how they do those fake proofs of 1 equals 2. That's what they do to you. They divide by 0, which allows you to make things happen that can't happen.
1 does not equal 0.
Oh, because x plus 5
Equals 2 equals
does
5.
equals 0. So if you divide, it's going to end up being the division by 0.
All right, 4 is what is solving by factoring when you have a term in front. Maybe I'll show this first one here. I have -30 x squared plus 9x plus 12 equals 0. Students forget how to do this. It shows you right there, but if you want to look at mine, okay. The first thing you might do is, do you see anything that's in common with these numbers? 3. Okay, so also, you may not want that to be negative. So maybe I'll divide everything by -3. And that might make things easier for me. Now, I can't divide by any more common stuff other than 1. So this marker's fading. Maybe this weekend I'll go get another set of markers somewhere. Okay, so what goes here is actually 10 times -4. Okay, what goes here is -3. You start listing factors. I don't care about the negative yet until I start getting numbers that I think can get me to add up to -3. 2 times 20, 4 times 10, 5 times 8. There we go. Okay, I want it to be negative when I add, so I want the 8 to be negative. There we go. So I know that that's the combination that I can multiply and that I will also add. So then I rewrite what I have. This is called factoring by grouping. I'm going to add 5x. I'm splitting the -3 into 5 plus -8, or 5 minus 8. So you see that 5x minus 8x is -3x. So I'm not changing it really. Minus the 4 equals 0. Okay. Then factor these two separately. Now, Thomas, same thing. Factor out what is in common. 5 and x, I'll go into both of these. 5x times 2x gives me 10x squared. 5x times 1 is 5x. Use that minus sign. If it's plus, use the plus. Now, I look for what's in common here. It's a 4. What I do is I copy my 2x plus 1 and I check to see that it is 2x plus 1. Check it. -4 times 2x is -8x. -4 times 1 is -4. So it checks out, equals 0. I factor what's in common between this entire term and this is multiplied, so it's the 2x plus 1. So it's what's in common times. Yes.
I got 5x minus 4 times -2x minus 1, but I guess it's because I didn't divide by -3, I divided just by 3.
It won't matter because what makes it 0 won't matter if it's negative out here, right?
Mm-hmm.
Negative something times 0, -0 times something. It won't matter that it's negative. The negative won't matter now. Okay, so here we go. How do I make, now here's the key, and then we'll go on break, and then we'll finish the review tomorrow, or on Monday. So the test will be on Tuesday, okay? So that's, hopefully that helps you guys. Okay, so we'll finish with this one. You need to make this group 0, and we don't care what, so when you make x, whatever you put for x, it's also got to be the x there. But if you make this an x that makes this 0, then it doesn't matter that it doesn't make this one 0. And then you switch it other way around. If you choose an x here that makes this group 0, then it doesn't matter that that x doesn't make this one 0 because of the 0 property of multiplication.
Divide by 2x plus 1.
So the shortcut is it's the opposite of this over that. So if you're good at this and you've done enough of these, it's just -1 over 2, comma, +4 over 5. Why is it those? Well, if you want, if you're not sharp with these and you need to work on them to understand it, set this equal to 0 so that you can get it to be 0. What makes 2x plus 1 equal to 0? Then you
subtract 1 and divide by 2.
Well, to solve it, that's what's going to give you the opposite of the 1, is because you have to put it over there. And then why is it divided by the 2? Because to solve it, you have to divide by 2. What does it look, if you're still not convinced, what does it look like when you put it back in here? Well, the -1/2, the half part is going to cancel out the 2, leaving you the opposite of that, which is going to make a 0. You want the opposite of that to make a 0, and you want it to be over that so that you can cancel that out. Okay, and it's the same over there. So these are, in orange here, are your solutions. You are dismissed. See, have a great week.
Thank you, Mr. Rosenthal.
Thank you, Mr. Rosenthal.
Welcome.
Son, I have a question.
Yes.
Because, actually, a couple things. When you have Tabletop Simulator, does everyone need to have it? I think maybe I asked this question before.
What?
Tabletop Simulator. Does everyone in the party need to have the app?
Hey Don, I'm teaching a Zoom lesson right now. Can I call you back later this afternoon? Okay, no problem. I'll call you back. All right, bye.
Wait, David.
Still not sure what you mean, David.
Do we have a science bowl?
Yes, we do.
Rosenthal?
When?
Yeah.
I don't know. It's
Can you explain how I got the X?
confusing. You can check Discord. I think he posted it there. Also,
Wait, hold on, David. Somebody's asking me a question. Go ahead.
Can you go over how to get the roots, the X?
From the beginning or from another color?
No, just X equals to -1/2 and 4 or 5, just that part.
Oh, the orange from the purple?
Yeah.
Okay. So the zero property is what people have a hard time with. Is if you have A times B equals 0, what needs to be true of A and B? What are different situations that can make that true?
They can be 0.
A could be 0. Does B have to be 0 if A is 0?
No,
Why not?
because 0 times.
Because of the zero property of multiplication is the answer to that question. Now, could B be 0 to achieve the same outcome?
Yeah.
Could they both be 0?
Yes.
Okay, so one, the other, or both. All right, so that's the principle behind all this. Okay, so one group in purple is the A, and the other group in purple is the B. So if this is the A, if you can get A to be 0, does it matter what B is?
No.
So what would make this 0? Okay, -1/2 would make this 0. It's the opposite of this divided by that. If this is -1/2, what's -1/2 times 2? The 2's cancel, leaving you -1. Because we made that negative, the opposite of that, the -1 will form a 0 pair with the positive one. That will make it 0.
Okay.
Now, if the X is -1/2 here, it won't make 0, but it doesn't matter, you said, because if this one is 0, then it'll, when you multiply it here to the other one, it will be 0. Then you just do the same thing here. The opposite of -4 is +4, and then you're gonna have to cancel out that 5, so it's divided by 5. So that if it's 4/5, which is my answer here, 4/5 times 5, the 5's cancel, you get +4 minus 4 gives you 0. It doesn't matter that 4/5, if I put 4/5 here, it won't give me 0, because if that one's 0 and you multiply it, you're gonna get 0.
Okay, thank you.
So, oh, by the way, I'm sure everyone, well, David, Daniel, did you get the news?
I have a question about the test.
Okay, question about the test.
What news?
So are you just going to post the PDF from the textbook where the test is?
Yes, I will have a PDF of the test that I come up with. I will take a picture of it when I have it ready to go, and I will put it in your Zoom test folder. But since we're not taking it Monday, we'll talk about that and how I want it and all that on Monday, and then Tuesday we'll take the test.
Are you going to take it out of the textbook or are you going to make it up?
Maybe a combination.
Thank you, Mr. Rosenthal. Have a good day. See you next week.
What were you saying?
No, I did.
I'm just curious. What is the name of the book again?
Why?
Because I want to be able to use it for studying purposes.
But you have it. Oh, you mean over the summer?
Huh? Yeah.
Over the summer, you should use our textbook to study. I don't recommend you use this book to study.
Are you sure? For at least in my case, it wouldn't be useful to use our textbook because the school I'm going to, I'm not even sure if they use it.
Then you should find out what book they use and get
Okay.
that. Yeah. In terms of the chapter that you're on now and for the test you're going to take now, you have all the whole book, you have the entire chapter as the lessons are taken right out of the book.
Okay.
Okay. Other questions?
Thank you, Mr. Rosenthal. Darn it.
I feel a little sad because I'm starting to feel like this is all coming to an end.
I know.
Yeah.
Thank you, Mr. Rosenthal. Have a good day. See you next week.
Oh, but it's not coming to an end.
Thank you.
Because you guys, a lot of you will be back next year and the fun will begin again.
Wait, David, what is the news?
No, I was talking about the news, Daniel. And the news is that they canceled the Science Bowl this year. The National Science Bowl has been canceled.
Yeah, poor Suzanne.
Yeah, no, poor Suzanne.
What if our Science Bowl is canceled too? In February.
It isn't.
How do you know?
Because this thing will probably be over by August or September.
Thank you, Mr. Rosenthal. Have a good day. See you next.
Wait, what is that, Mr. Rosenthal?
It's what my son
Ah,
earlier. He
again.
made this Lego invention.
Cool.
All right, now, thank you, Mr. Roscoe.
Wait.
Have a good day. See you next
When
week.
is
No,
time?
there's
Son,
no
you're,
wait.
son,
There's
you're
no
on
wait.
Discord, right? Son,
Yeah,
you're
but-
on Discord, right?
Yes.
Okay.
I don't think he said anything about when it is.
He said 10:30.
When?
10:30 today.
Thank you, Mr. Roscoe. Have a good day.
Okay.
See you
Bye,
next
Mr.
weekend. This time is
Rosenthal.
final.
Bye,
Bye,
Mr. Rosenthal.
guys.
Bye.
See ya.
Thank you.
Anybody else have anything they want to go over?
Could you please it kind of explain the different forms of the equation? I don't know. I'm kind of lost on that.
You know this form?
Standard.
Mm-hmm. What do you want to know about it? Where the vertex is or where the roots are?
No, I think I have that. It's just how to convert between forms. maybe.
Oh, how to convert between forms. Okay. Well, to get it into intercept form, you need to factor it. Okay? If it's not factorable, you have to find the roots using the quadratic formula. Okay? Because in intercept form, it looks like this. So in order to get it into that form, you have to know what P and Q are. All right? And you have to know what A is. All right? So the first thing you're going to want to do is, if you're trying to get this, is that you want to find what the roots are. Well, you said in standard form you know how to find the roots. You can either factor or use the quadratic formula. Then you would plug those in for P and Q, right? And I believe A would just be A. A has to be the same. Okay, so your A stays the same. Okay, now, if I want to get it into vertex form, you have to complete the square. So if I have this, now do you want it the complicated way or do you want an actual numerical example?
I mean, I don't know, whichever you think's better.
Well, I can do it in this form and convert it, but it's going to get messy. Or I can do it numerically, or I can do it both.
Do the messy one so that I can see where the variables end up.
Okay, great. All right. So you're going to want to bump that C over, and you're going to want to get rid of that A. You want to factor out an A. So how do I factor out an A from these two? Pull an A out. A times what is AX squared? X squared. A times what is going to give me BX? That. Think about it. A times B over A, the A's cancel, right? And what are you left with? BX. Plus C, we're going to leave it out here. Now, this is easy numerically if these are factorable, or if that A is 1, you don't even have to worry about it. You don't have to factor out a 1 if that's a 1. If this is a 2 and that's a 4, then it factors out quite easily. Okay? Now that we have that, you complete the square in here. And the way we complete the square is you take half of this and you square it. Right? You remember that? You take half of the B over A term here and you square it.
Yeah.
What is half of B over A? It's just B over 2A. Okay? Now, B over 2, do you need to see that? How B over A, half of it is B over 2A? Or do you understand?
No, that makes sense. That makes sense.
Now, when you square that, you get, we're going to add that, B squared over 4A squared. That's the square of B over 2A. But if I add it here, then what I want to do is I want to take it away over here. Now I'm adding the same thing that I'm taking away. Oh, that's not quite right. I didn't add that. I added this time. Don't forget, I added that times the A. Now, if A is 1, it's not a big deal. You don't have to do it. You just you subtract the same thing that you have there. But if A is something else, then you're actually not adding this, what you see, to the right-hand side of the equation. You're adding this times the A, because the A will distribute and multiply to it, right? So I actually need to subtract, not this, I need to subtract this times the A, which is what? Let's see, B squared over 4A squared. How do you multiply those? What do you get? The A cancels out one of the A's. You just get B squared over 4A. That's what I'm subtracting. That's what this is. I added this value that wasn't, remember, it wasn't there at all. Once I put this there, remember, it's not as is, it's A times that, which is this, B squared over 4A. So I added B squared over 4A, so I have to subtract it, which means I've netted a 0. I didn't change my equation.
Okay.
Now what I've created is a perfect square trinomial. When you complete the square, you create a perfect square. Okay, this is a perfect square, this is a perfect square. Perfect squares factor into, and I'm going to make sure I have that A there, they factor into a binomial squared. So it's the square root of that plus whatever half of that was, because that was how we got that. We squared half of this. It was B over 2A. And when we squared it, we got this, right? So that's what it factors into. And then it's going to be plus whatever's here. So it's going to be okay? And this is it. This is what you're in the form now. Okay? H, if you notice, since this is minus and that's plus, negative B over 2A is the x coordinate of the vertex, which is your H. Your K is found at whatever your C was, minus B squared over 4A, which is a nice formula to have on your test. Negative B squared over 4A will give you the y coordinate of the vertex. We didn't have that. We didn't do that in class. If you take your C and you subtract B squared over 4A, these two together, if you use this formula, we always got negative B over 2A and then we plugged it back in. Instead of doing that, you can find negative B over 2A and then you can separately just do this. Take your C and subtract B squared over 4A if you want it. It's not, it probably takes about the same amount of time. Now, numerically, did you have any questions before I went to a numerical example?
No, not really.
Did you want a numerical example, or do you feel like you get the process?
I feel like I get the process. I think the homework's going to be enough.
Okay. And again,
thank you so much.
There will be office hours on Monday as well. Okay, so if you run into any trouble, you can have those questions ready to go for me.
Perfect. Thanks.
All right, you betcha. Russell, anything? No. All right. Have a great weekend. I'll see you on Monday.